January 1940. A bitter wind swept across the tarmac of an industrial airfield on the outskirts of Seattle. Steel and rivets gleamed under a pale winter sun. The aircraft sat motionless, colossal and strange, its fuselage a blend of promise and awkward angles. Engineers huddled around clipboards, their breath visible in the cold air, while the engines, silent for now, promised a roar that never came without hesitation. Inside the cockpit, the control panels gleamed with polished brass and rudimentary gauges, technology meant for smooth commercial flights, not the rigors of combat. From afar, it looked majestic, a machine built to conquer skies and carry men in comfort. But those who had flown it whispered unease. Controls balked, engines sputtered under strain, and the design wavered between innovation and catastrophe. Half a world away, Japanese officers would soon inspect this very airframe. They saw potential where Americans saw risk, ambition where engineers saw limitations. A single purchase would transform a rejected airliner into an instrument of war, and into what history would remember as one of the deadliest miscalculations of the skies. The engines fired. The plane shuddered. History was about to take off. The 1930s were an era of ambition in aviation, but also of experimentation and missteps. Commercial airlines in the United States were emerging as symbols of modernity, seeking aircraft that could carry passengers efficiently, safely, and profitably across long distances. The technological frontier had moved rapidly since Charles Lindbergh's transatlantic flight in 1927. Aircraft manufacturers raced to design larger, faster, and more comfortable airliners. Among these efforts was a particular U.S. airliner developed in the late 1930s. It was ambitious in scale, larger than almost anything in commercial operation at the time. Its designers envisioned a craft that could transport dozens of passengers in relative comfort over thousands of miles. Structurally, it relied on a high-wing monoplane design with multiple engines, intended to provide redundancy and lift. Inside, cabins were spacious, with provisions for sleeping berths and lounges, luxury in a period when air travel was still a novelty. Yet ambition does not guarantee success. Airlines tested the prototype with careful scrutiny. Problems emerged almost immediately. The engines, designed to sustain long-range flights, were prone to overheating. The landing gear, heavy and cumbersome, strained under the aircraft's own weight. Structural flexing during high-speed maneuvers caused small cracks to appear along wing spars, a sign of a deeper design flaw. Flight tests revealed poor handling characteristics, sluggish responses, difficulty maintaining altitude in turbulent air, and a tendency to pitch forward during landing. Despite the aircraft's innovative features, American Airlines rejected it. Profit margins, safety concerns, and the unreliability of its systems made it commercially unviable. The project was considered a failed experiment, a machine too ambitious for its time. Engineers who had poured years into its design faced disappointment. Their work, brilliant on paper, had failed in the unforgiving reality of flight. But in the eyes of the Imperial Japanese Navy, this rejection was not a deterrent. It was an opportunity. Japan's military planners had watched global aviation developments closely, studying designs from Britain, Germany, and the United States. Their ambition was clear: to develop a fleet of long-range bombers capable of projecting power across the Pacific. At the time, Japanese aviation was limited by industrial capacity, engine technology, and aeronautical expertise. Purchasing an advanced foreign design promised a shortcut to technological parity with Western powers. The United States, focused on commercial viability, had overlooked one critical factor: Japan's willingness to modify and militarize the aircraft. For the Japanese, passenger comfort and airline profitability were irrelevant. They were concerned with payload capacity, range, and operational ceiling. The rejected airliner, large and robust, could theoretically carry bombs instead of passengers and fly farther than any domestic Japanese design. Negotiations began quietly. Japanese engineers inspected the prototype, noting every system, every structural element. They studied the engines, the fuselage, the control surfaces. Their objective was clear: adapt this aircraft for military use, improve its range, reinforce its structure, and equip it with defensive armaments. Each measurement and diagram taken from the American prototype would serve as the blueprint for a new generation of bomber, one that promised power and intimidation. Yet transforming a commercial airliner into a military bomber was far from straightforward. American designers had optimized the craft for comfort and efficiency, not combat. Reinforcing the fuselage to carry bombs added weight that stressed the engines further. Mounting defensive turrets altered aerodynamics. Even minor modifications risked catastrophic failure. Engineers in Japan were entering uncharted territory, tasked with reshaping an aircraft that had already failed in the controlled environment of civilian aviation. By mid-1939, plans were underway to purchase the prototype and its design rights. What the Americans had deemed unsellable would soon enter Japanese production lines. The aircraft's journey, from a rejected airliner on a Seattle tarmac to the heart of Japan's wartime industry, was only beginning. The stage was set. A machine of ambition, flawed and cumbersome, was about to cross oceans and cultures, carrying with it the weight of human expectation and the peril of miscalculation. By late 1939, the Imperial Japanese Navy had fully committed to acquiring the rejected American airliner. Japan's strategic vision was ambitious, a long-range heavy bomber capable of striking distant targets across the Pacific, supporting naval operations, and threatening Allied positions. At a time when Japanese aviation relied largely on medium bombers and floatplanes, the introduction of a true heavy bomber promised to redefine the balance of power. Japanese engineers faced a monumental task. The original airliner had been designed to carry passengers and cargo, not bombs. Every modification required careful calculation. Reinforcing the fuselage to accommodate bomb bays added thousands of kilograms to an already heavy frame. Mounting defensive gun turrets and armor plating altered the aircraft's center of gravity, making it more difficult to handle in flight. Engines, already under stress in the civilian design, now had to sustain heavier loads over extended distances. Each modification risked overtaxing the aircraft's systems, but the Imperial Navy pressed forward, driven by strategic necessity and technological ambition. The design process was meticulous. Blueprints were translated, often with subtle changes to adapt to Japanese measurement standards. Engineers dissected every component: wing spars, hydraulic systems, landing gear, and control surfaces. Attempts were made to strengthen the airframe with reinforced alloys, and Japanese engines were tested as replacements for the original power plants. In workshops across Tokyo and Nagoya, craftsmen labored to marry foreign technology with domestic industrial capacity. The work was painstaking and expensive, but the Navy believed it would yield an aircraft capable of long-range dominance. Despite this dedication, early prototypes revealed persistent problems. Flight tests showed that weight distribution remained a critical issue. Engines overheated under full load, particularly in tropical climates. Turrets and bomb bays compromised aerodynamics, resulting in sluggish handling and limited maneuverability. Pilots reported difficulty maintaining altitude when fully loaded, and landing the aircraft safely demanded skill few possessed. It became increasingly clear that a passenger airliner, even one as large and advanced as this, was ill-suited for military adaptation. Nevertheless, the Japanese Navy pressed forward, driven by urgency and strategic vision. Tensions in East Asia were escalating, and the Pacific theater loomed. Commanders believed that a single long-range bomber could extend Japan's reach, protect its fleets, and deliver decisive blows to distant enemies. The airliner-turned-bomber represented not just a machine, but a symbol of Japan's industrial ambition and technological aspiration. By early 1940, production lines were established. Factories buzzed with activity, the rhythmic pounding of rivets and clanging of tools filling the air. Japanese workers, many of them inexperienced with aircraft of this scale, labored tirelessly to assemble each fuselage, wing, and engine. Engineers conducted repeated inspections, testing structural integrity and flight readiness. Every successful assembly was celebrated, yet each aircraft also carried a silent uncertainty. Would it survive its first mission? Could it perform as envisioned? Beyond the technical challenges, logistical and operational concerns emerged. Maintenance was complex, spare parts were scarce, and the aircraft's sheer size limited the number of airfields capable of accommodating it. Crews underwent accelerated training, learning to manage unwieldy controls, overheating engines, and the delicate balance of fuel and bomb loads. The human element, skill, endurance, and courage would prove as critical as the machine itself. By mid-1940, the first modified aircraft were ready for deployment. The Imperial Japanese Navy had turned a rejected American airliner into a prototype heavy bomber, a project representing both ambition and risk. Yet early flights hinted at an uncomfortable truth: the aircraft's flaws could not be entirely masked. Its weight, fragility, and mechanical unreliability foreshadowed the tragic legacy it would carry in combat. The world would soon witness the consequences. From Seattle's industrial airfields to Japan's production lines, a machine born of ambition and human ingenuity was about to enter the crucible of war, a crucible for which it was ill-prepared. For the pilots and crews, the aircraft was a paradox, awe-inspiring in size, yet terrifying in its unpredictability. Early training flights revealed a machine that demanded constant attention, precision, and nerves of steel. Engines would overheat without warning, controls were sluggish, and the bomber's massive wings made it susceptible to sudden stalls and turbulence. Veteran pilots described the experience as balancing on a knife's edge. One navigator, recalling his first flight, noted the deafening roar of the engines vibrating through the fuselage, every rivet seemingly screaming under stress. Crew camaraderie became essential. Mutual trust was the only shield against mechanical failure. Lives were bound to flawed steel, and each sortie became a gamble with fate. Tactical angle. Strategically, the Imperial Japanese Navy envisioned this bomber as a long-range strike instrument. Its size promised unprecedented payload capacity and range, theoretically allowing Japan to threaten targets deep across the Pacific. However, in practice, the aircraft's operational limitations undermined its tactical potential. Slow acceleration, limited maneuverability, and poor climb rates made it vulnerable to interception. Mission planners soon realized that the bomber's theoretical advantages were counterbalanced by its real-world weaknesses. The concept of a single strategic heavy bomber capable of decisive strikes began to crumble under the pressures of war. Technological angle. Technologically, the bomber represented a collision between ambition and inadequacy. The original airliner's engines, never designed for combat stress, were prone to overheating and failure under full load. Reinforced fuselages added weight that strained both propulsion and structural integrity. Defensive turrets compromised aerodynamics, creating turbulence that further destabilized flight. Attempts to integrate Japanese engines and systems proved only partially successful. While the design embodied forward-thinking concepts, multi-engine redundancy, spacious internal layout, and modular construction, the translation from civilian airliner to combat-ready bomber exposed fundamental engineering miscalculations. In laboratories and test fields, engineers documented engine failures, structural stress fractures, and control instability, highlighting a machine that could not reliably meet the demands of war. Leadership angle. Japanese military leadership faced a dilemma: the pressure to project air power versus the reality of flawed technology. Senior officers were captivated by the aircraft's potential, sometimes overlooking technical warnings. Decision-making relied on optimism, prestige, and strategic necessity. The bomber became a symbol of ambition as much as capability. Field commanders were ordered to deploy the aircraft despite its flaws, reflecting a chain of command that prioritized vision over practicality. Leadership's choices magnified the risks faced by crews and engineers alike, embedding a human cost within every operational decision. Moral/strategic angle. Beyond mechanics and strategy, the aircraft carried moral weight. Every flight placed trained young men in jeopardy. Commanders, aware of the bomber's flaws, were forced to weigh potential gains against almost certain losses. The machine became an instrument of both ambition and tragedy, illustrating the consequences of technological overreach. The ethical dimension. Sending crews into combat aboard a fundamentally unreliable aircraft echoed the broader moral challenges of wartime innovation. The bomber's story was not just about machines, but about humans grappling with the consequences of hubris and necessity. The interplay of human skill, tactical intent, technological limits, leadership decisions, and moral responsibility framed the aircraft as a complex study in wartime innovation. Each angle highlighted a tension between aspiration and reality, illustrating why the bomber, though conceptually impressive, would ultimately falter in execution. Enemy/Allied perspective. From the perspective of Allied intelligence and pilots, the aircraft initially appeared as a potential threat. Reconnaissance photos showed a massive, multi-engine bomber capable of long-range operations, prompting concern over Japanese strategic reach. Yet, reports from early encounters revealed its vulnerabilities. Pilots noted sluggish acceleration, poor defensive coverage, and limited maneuverability. Allied planners began to understand that while the bomber could carry a substantial payload, its operational weaknesses made it susceptible to interception. In combat reports, air crews described large, lumbering silhouettes, sometimes intimidating at a distance, but perilous once engaged. The bomber's reputation among enemies became a mixture of fear for its potential damage and recognition of its practical fragility. Industrial/production angle. The bomber's transition from prototype to production exposed Japan's industrial limitations. Factories struggled to replicate foreign engineering methods while integrating domestic materials. Quality control became a constant battle. Welds failed, engines were improperly calibrated, and assembly errors occasionally grounded entire units. The workforce, unaccustomed to aircraft of such size and complexity, faced immense pressure to meet production quotas. Each aircraft required months of labor, meticulous inspections, and repeated corrections. Delays and material shortages compounded operational difficulties, revealing a gap between strategic ambition and industrial capability. The bomber, in effect, became as much a test of Japanese industry as it was of aeronautical design. Leadership/strategic reassessment angle. By 1941, Japanese commanders began to confront the bomber's limitations more candidly. Operational deployment revealed that crews were losing aircraft at alarming rates, not to superior enemy tactics, but to mechanical failure and design flaws. Commanders faced difficult decisions: continue risking lives to deploy an unreliable machine, or halt operations and reallocate resources to more manageable designs. These assessments highlighted a critical lesson in leadership. Technological aspiration must be tempered by operational realism. The bomber's failure became a case study in overextension, forcing reevaluation of Japan's heavy bomber strategy and the pursuit of more practical alternatives. Human/psychological angle. The human toll was profound. Aircrews confronted not only enemy fire but the constant threat of catastrophic failure from the bomber itself. Pilots described flights where engine fires or hydraulic malfunctions were as deadly as anti-aircraft guns. Stress and fatigue mounted, affecting decision-making, morale, and cohesion. Engineers, aware that their labor had not produced a reliable aircraft, faced frustration and guilt. The bomber became a symbol of human cost embedded in technological ambition. Dreams of long-range dominance exacted a tangible price in lives and psychological strain. Diaries, post-war testimonies, and mission reports all reflect the tension between hope and fear, pride and regret. Moral/ethical angle. Finally, the bomber raised profound ethical questions. Was it justifiable to deploy a fundamentally flawed machine in combat? Commanders and engineers faced the tension between national objectives and individual risk. Each mission flown carried not only bombs, but the implicit gamble with human life. The aircraft's story, therefore, is inseparable from the moral calculus of wartime decision-making. It illustrates the dangers of prioritizing strategic ambition over practical safety and the ethical burden borne by those responsible for both creation and deployment. Through these angles, the aircraft emerges as more than a flawed machine. It becomes a prism reflecting human ambition, industrial struggle, operational reality, and moral complexity. Its story foreshadows the coming operational struggles, setting the stage for the intense, often tragic consequences that would define its combat history. By mid-1941, the first modified bombers were operational. Their deployment was heralded as a milestone in Japan's strategic air power. Crews trained rigorously, absorbing every nuance of the aircraft's quirks: engine overheating, sluggish control response, and the delicate balance required during takeoff and landing. Mission planners envisioned long-range strikes against Allied installations, confident that the bomber's range and payload could deliver decisive blows. The initial sorties, however, revealed the stark reality. On its first extended combat mission over the South Pacific, a fully loaded aircraft struggled to maintain altitude. Turrets and armor compromised aerodynamics, creating turbulent airflow that rocked the fuselage. Engines, stressed beyond their design limits, began to overheat midway through the flight. Pilots reported vibrations and structural flexing, audible through the cabin like ominous warnings. Some bombers barely reached their targets, others never returned. Despite these early failures, the Navy pressed forward. Each mission represented not just a tactical objective, but a test of human endurance and engineering resilience. Aircrews, many young and inexperienced, faced terrifying odds. Mechanical failures and enemy engagements combined to create a deadly environment. Pilots had to manage overheating engines while dodging anti-aircraft fire. Gunners struggled to track nimble fighters while balancing on unstable turrets. The bomber's sheer size offered some protection, but only marginally, and losses mounted with each sortie. That on one particularly harrowing mission in late 1941, a squadron of 6 bombers set out for a distant Allied-held island. The journey should have been straightforward, a demonstration of the aircraft's long-range capability. Yet turbulence, engine fires, and miscalculations in weight distribution reduced their formation to 4. By the time the squadron reached the target, only 2 bombers were fully operational. The strike itself inflicted minimal damage, but the human cost was immense. Over half the crews were lost, many not to enemy fire, but to the aircraft's own mechanical failures. Reports from the field filtered back to Naval Command. Engineers examined mission logs, flight data, and damage reports. The bomber, once envisioned as a strategic game-changer, now appeared as a liability. Yet military leadership, invested in its potential and constrained by timelines, continued to authorize missions. The aircraft had become both symbol and cautionary tale, a marvel of ambition but a nightmare in execution at the same time. The psychological impact on crews was profound. Pilots developed strategies to compensate for the aircraft's limitations: gradual climb rates, careful throttle management, and contingency plans for engine failure. Some called it flying a coffin with wings. Every takeoff was a confrontation with uncertainty. Every landing a test of nerves and skill. Morale wavered, but training and camaraderie provided a fragile buffer against despair. Technologically, failures were mounting. Engine replacements were frequent, airframes required constant reinforcement, and turrets often jammed mid-flight. The industrial capacity of Japan struggled to keep pace with repairs and replacements, and production bottlenecks further limited operational availability. Commanders faced difficult choices: deploy a flawed aircraft and risk lives, or withhold it and sacrifice strategic reach. The tension between ambition and reality reached a crescendo as the bomber continued its operational trials. It became evident that the machine could not deliver the strategic advantage the Imperial Navy had envisioned. Losses were mounting, and the combination of mechanical unreliability and enemy action was exposing the aircraft's fatal weaknesses. Crews returned from missions battle-weary. Engineers faced mounting frustration, and commanders had to reconcile the ideal of technological superiority with the brutal reality of failure. The stage was set for the second part of the climax, a period in which operational losses, strategic reassessments, and industrial limitations would converge, revealing the full scope of the bomber's disastrous legacy. As 1942 unfolded, the bomber's operational record worsened. Early optimism gave way to grim reality. Mechanical failures, design flaws, and industrial shortcomings converged into a lethal combination. Squadrons deployed to the Pacific Theater faced not only enemy fighters and anti-aircraft fire, but the aircraft's own unforgiving engineering. Missions that were intended to project Japanese air power across vast distances now became exercises in endurance, improvisation, and survival. One notable campaign in mid-1942 illustrated the aircraft's limitations with brutal clarity. A formation of 7 bombers, loaded with maximum payloads, attempted a strike on a strategically vital Allied base. Turbulent weather compounded their struggles. Engines overheated within hours, hydraulic failures limited turret operation, and structural flexing threatened wing integrity. Only 3 bombers returned to base, each bearing extensive battle and mechanical damage. The operation's strategic gains were negligible. The human cost was catastrophic. Mission reports bluntly documented what engineers and pilots had feared. The aircraft could not reliably perform its intended function. Leadership was forced to confront this sobering truth. Replacing lost aircraft was slow, as production lines continued to battle material shortages, inexperience among laborers, and the challenges of integrating foreign design elements into Japanese manufacturing processes. Commanders now faced a stark choice: continue deploying a fundamentally flawed bomber at the risk of human lives, or abandon its use entirely and reorient strategy around more reliable aircraft. The decision carried profound operational and moral weight. Psychologically, crews experienced mounting stress. Pilots developed intricate procedures to cope: staggered throttle adjustments to reduce engine strain, careful load balancing, and precise communication to coordinate turret defense. Each flight became a test of skill, patience, and nerves. Some described the experience as an endurance trial rather than a mission. The bomber's flaws demanded constant vigilance, leaving no room for error. Diaries from surviving crew members recount moments when engines caught fire mid-flight, requiring emergency landings in hostile or remote terrain. The aircraft's very design seemed to conspire against survival. The technological limitations were stark. Despite repeated modifications, engineers could not fully compensate for excessive weight, poor aerodynamics, or unreliable engines. Reinforced fuselages and added armor further stressed propulsion systems. Turret installations, intended to protect crews, often jammed or slowed the aircraft's responsiveness. Even minor repairs could take weeks, delaying deployment and limiting operational effectiveness. Each failed mission underscored a single, unavoidable truth: the bomber's conception as a long-range, heavy-strike aircraft was fatally flawed. By late 1942, operational doctrine shifted. The bomber was increasingly restricted to secondary missions, such as limited reconnaissance, training, or missions in lower-threat environments. Commanders recognized that using the aircraft in high-risk combat would continue to yield disproportionate losses. Reports emphasized that the bomber's failures were not merely tactical, but systemic. Industrial capability, engineering adaptation, and human endurance were all stretched beyond sustainable limits. The convergence of these failures reached its peak during a final series of high-profile operations. Losses were staggering. Entire crews perished not from enemy fire, but from mechanical collapse, engine failure, or structural failure during critical maneuvers. Historians later noted that the aircraft's combat record exemplified the dangers of overambitious design, industrial strain, and misjudged strategic deployment. Each sortie became a cautionary tale, reinforcing lessons about the intersection of technology, human skill, and wartime ambition. By the end of 1942, the bomber had earned a reputation among Japanese pilots as one of the most unreliable and dangerous machines they had flown. Its story, a rejected American airliner transformed into a heavy bomber, was a narrative of ambition colliding with reality. Lives were lost, strategic opportunities compromised, and industrial resources consumed, all for a machine that could not fulfill its intended purpose. Yet from the wreckage of these failures, critical lessons emerged. Engineers refined techniques, production lines learned the limits of foreign adaptation, and military planners reassessed operational doctrine. The bomber's disastrous operational history illuminated the complex dynamics of aircraft design, industrial capability, and human endurance in wartime. It also set the stage for Japan to focus on more reliable, purpose-built designs, ensuring that future heavy bombers would avoid the catastrophic pitfalls of their ill-fated predecessor. The stage was now set for the aftermath, an exploration of the consequences, losses, and enduring impact of this ambitious but flawed aircraft. By 1943, the full scope of the bomber's failure was evident. Operational records and mission reports painted a grim picture. Of the dozens of aircraft produced, a significant percentage had been lost to mechanical failure rather than enemy action. Engine fires, landing accidents, and structural failures were commonplace, with aircrews facing extraordinary risk simply to complete routine missions. The human toll was staggering. Hundreds of trained pilots and gunners had perished, not from combat alone, but from the unforgiving consequences of flawed engineering. Strategically, the bomber failed to deliver the advantages the Imperial Japanese Navy had envisioned. Its limited success in long-range strikes was overshadowed by disproportionate losses and minimal damage inflicted on enemy installations. Commanders reassessed the aircraft's utility, gradually removing it from frontline operations. Resources previously allocated to its production, materials, engines, skilled labor, were redirected toward more reliable bombers and fighters. The operational experience revealed a harsh lesson. Ambition without practical viability could squander both lives and national resources. Industrial consequences were equally significant. Factories had expended months producing aircraft that could not sustain combat operations. Labor-intensive construction, combined with the need for repeated repairs, strained Japan's already limited wartime industrial capacity. Engineers documented countless modifications, each attempt to fix structural or mechanical flaws, consuming time and materials. Reports highlighted the mismatch between foreign design elements and domestic production capabilities, emphasizing that technological importation without adaptation to local realities could hinder, rather than help, war efforts. Despite the aircraft's failures, the Imperial Japanese Navy extracted critical knowledge. Maintenance procedures were refined, engines were better understood, and lessons in weight distribution, structural reinforcement, and operational planning informed subsequent bomber designs. While the bomber itself would never achieve operational success, it became an inadvertent training ground for Japanese engineers, pilots, and commanders. The tragedy of wasted lives was paralleled by the slow accumulation of technical and tactical expertise. Morale among surviving crews was fragile. The psychological strain of operating an aircraft prone to catastrophic failure left lasting effects. Diaries and post-war testimonies describe the anxiety before every flight, the meticulous attention required to avoid disaster, and the camaraderie that sustained crews under extreme stress. These human stories highlight the hidden cost of technological overreach. It was not only machines that failed, but the confidence, optimism, and sometimes lives of those who depended on them. The broader Allied perspective added another dimension. Intelligence reports confirmed the bomber's operational weaknesses, providing insight into Japanese capabilities and limitations. Allied planners adapted their strategies, exploiting the aircraft's vulnerabilities while minimizing their own risks. The failed bomber thus indirectly influenced the conduct of air campaigns, shaping operational choices and the allocation of resources in the Pacific Theater. By mid-1943, the aircraft had effectively ceased to be a frontline asset. Its operational history, though short and marked by failure, left an indelible imprint on Japanese air strategy, engineering practices, and wartime decision-making. The bomber's story was one of high ambition confronted by harsh reality, a case study in the costs of technological misjudgment during war. This naturally sets up Aftermath, Part 2, where we will examine long-term consequences, shifts in industrial strategy, and the aircraft's enduring legacy in both human and technological terms. By late 1943, the Imperial Japanese Navy had largely withdrawn the bomber from frontline service. Its operational record was clear, losses had outpaced achievements, and missions undertaken with the aircraft had produced minimal strategic gain. Commanders acknowledged that deploying it in high-risk operations was untenable. The aircraft's legacy was no longer one of potential dominance, but of caution, an enduring reminder of the limits of ambition when technology, human skill, and industrial capacity collide. The bomber's failures prompted a re-evaluation of Japan's heavy bomber program. Engineers, familiar now with the pitfalls of adapting foreign designs, began focusing on purpose-built aircraft. Lessons in weight distribution, engine reliability, and structural reinforcement informed subsequent projects. Production lines were retooled for machines better suited to Japanese industrial realities, ensuring that future designs were both ambitious and achievable. In this sense, the failed bomber served as an inadvertent teacher, a costly, tragic instructor whose failures shaped more effective aircraft to follow. Human consequences were profound. Survivors carried the physical and psychological scars of repeated exposure to risk. Many pilots and crew members recounted the fear of mechanical failure as more immediate than enemy fire. Memoirs, post-war interviews, and internal reports detail the constant vigilance required in every flight, the improvisation necessary to prevent catastrophic accidents, and the camaraderie that sustained crews under extreme stress. The bomber became a symbol of the tension between human endurance and technological fragility, illustrating how innovation without reliability can exact an extraordinary human cost. Industrial lessons were equally significant. Factories learned that attempting to replicate foreign designs without adaptation could consume vast resources for minimal operational return. Quality control procedures were revised, material standards improved, and production schedules adjusted to match realistic capabilities. The experience reinforced a fundamental truth: strategic ambition must align with industrial capacity and practical feasibility. These insights informed Japan's later wartime aircraft development, influencing not only heavy bombers but also fighters and reconnaissance planes. Strategically, the aircraft's failure indirectly benefited Allied forces. Intelligence gathered from encounters with the bomber revealed its vulnerabilities, allowing enemy planners to exploit its weaknesses and adjust defensive strategies. Japanese command, aware of the aircraft's limitations, gradually shifted resources to more reliable and versatile aircraft types. The failed bomber's story, therefore, extended beyond Japan, shaping the operational environment in the Pacific and affecting the trajectory of air campaigns. Yet, despite its failures, the bomber retained symbolic significance. It represented the ambition of a nation striving to match Western technological achievements. Its initial promise, though unrealized, inspired engineers, pilots, and strategists to confront the challenges of scale, range, and payload in aviation. The aircraft became a cautionary tale, a tangible example of how vision, when untempered by practicality, can yield disaster even in a technically sophisticated society. In historical retrospect, the bomber's impact is twofold. On one hand, it is remembered as one of the worst heavy bombers ever deployed, technically flawed, operationally dangerous, and strategically ineffective. On the other, it contributed to the evolution of Japanese aeronautical engineering and military strategy. The aircraft's failures forced hard lessons in design, production, and deployment, influencing subsequent generations of aircraft and shaping the Imperial Japanese Navy's approach to air power. The stage is now set for the reflection/closure, a calm, cinematic exploration of what this story reveals about human ambition, technological risk, and the enduring costs of war. The story of this bomber is not merely a tale of machinery, but a meditation on ambition, ingenuity, and human cost. From a rejected American airliner to a Japanese heavy bomber, its journey illustrates the perilous gap between vision and reality. Engineers, pilots, and commanders all confronted the limits of what technology could achieve under the pressures of war, and the consequences were immediate, tangible, and often tragic. There is a certain poetry in failure. The aircraft embodied the aspirations of a nation striving for power, the skill of engineers attempting the impossible, and the courage of crews who faced daily uncertainty in the skies. Each engine fire, each structural failure, each mission that ended in catastrophe became a lesson, etched into human memory, industrial practice, and military strategy. The bomber's flaws were glaring, yet its existence propelled progress, forcing a reassessment of what was feasible and what was hubris. In the larger scope of history, the aircraft reminds us that innovation cannot be divorced from practicality. Ambition without reliability can squander lives, squander resources, and compromise strategy. Yet, even in failure, there is knowledge gained, experience accumulated, and expertise refined. Japan's subsequent aircraft designs, improved production methods, and operational doctrines all carry the echoes of lessons learned from this tragic machine. Ultimately, the bomber's story is a reflection on the delicate balance between human aspiration and human limitation. It is a reminder that in war, technology is not neutral. It is entwined with courage, fear, decision-making, and consequence. The machine, as monumental as it was flawed, leaves behind not only a record of failure, but also a quiet testament to the resilience, skill, and sacrifice of those who dared to fly it. The engines that once roared over the Pacific have long fallen silent. Yet in their echoes remain the enduring lessons of ambition, error, and the fragile triumphs of human endeavor. The skies remember, and history never forgets.